There's PCB rework as well, which is something that we do an awful lot of. We have done a project where it's been to 1 million PCBs.
Wow.
Yeah.
Per month.
Yeah. The way the industry works so quickly like that will actually work in our favour for Reclamation. And I think it's going to make Reclamation a little bit more standard.
And what are the sort of technologies involved in actually getting the heat into those components? Is it hot air? Is it infrared?
Like I say, going back sort of 5 years ago, talking to some customers about Reclaim, they didn't even want to discuss it particularly. And now it's become, it's almost become the thing.
Welcome everybody to the next instalment of the World Made Better podcast series. And today is going to be a very interesting day because I am joined by Rob Ronan, who is the sales manager for UK and Ireland for Retronix. Now, Retronix is a company embedded in the whole subject of sustainability and a real driving force in terms of the circular economy in the electronics industry. So I'm going to hand over to Rob now and just ask for a sort of summary of the business. And I'm going to start with my classic opening question, which is, Rob, I'm an engineer. Mm-hmm. I'm at a manufacturing company. What challenge or problem am I going to have where Retronix and its services are the solution? Just sort of set the scene.
Yeah. I mean, it depends because we've got so many different avenues, so many different services that we offer. Probably still the bread and butter of the company is alloy conversion.
Okay.
So that can be for the military aerospace industry. Obviously they can't still source leaded components, so they have to source the lead-free parts, and then they'll send them to us. We'll alloy convert them to leaded, send them back. So this opens up another avenue for our component supplier customers. If they are being approached by a military aerospace customer, we need 10,000 of these, 20,000 of these, and they can't source them. They know they can come to us. They source them, send them to us. We'll alloy convert them. We'll either send them back to them or we'll send them directly on to the customers. In a lot of cases, we're linked with a lot of the customers, so we've got good relationships from that point of view.
Sure.
And then there's PCB rework as well, which is something that we do an awful lot of. And that can be a batch of 5 right up to, we've had PCBs delivered by pallets before. Right. Because, tens of thousands of PCBs that need some kind of rework done. And component testing. So again, during the component shortage issues, a lot of customers had to dip outside of their agreed supply chain. So they're having to source somewhere they've never sourced before. So to put their end customers at minds at ease, they'll come to us. We'll do electrical testing on that part just to prove it, or counterfeit testing.
So that's an example of confidence building in terms of testing components. And those other 2 services you spoke about, the alloy conversion, that's about keeping products, I guess, in service longer, or designs in service longer. And I think you were also going to mention Reclaim.
Yes, yeah. Component Reclaim, which is slowly starting to become, I think it may even overtake the alloy conversion, to be honest, over the next 5 years. Is becoming probably, one of the top services that we offer. And again, that's anything from a customer that's made a mistake on a PCB and there's a very expensive part on it they don't want to waste. So it could be 10, 50 PCBs they send to us to reclaim, or it could also be, some of the bigger customers with data center PCBs that need to reclaim parts as well.
That set the scene in terms of the sort of range of services that you guys supply. And in terms of the brand itself, in terms of the organisation, can you just give us a little bit of background? So where did the company originate? What was its path to where it is now? And in particular, your involvement with Jabil?
We're in our 33rd year as a company, as Retronix. Obviously, back then, the area that we're based up in Scotland was, it was full of Motorola. There was all those companies up there. It was jokingly referred to as Silicon Glen at the time, I believe. So it came out of that, and it grew. We sort of grew with our customers. Really, it was as a customer came to us with a demand, if we with a requirement that we didn't have, we'd look at adding that, and we've kind of been like that for the last 33 years. Even in the 9 years I've been there, we've added 2 or 3 new services that just sort of follow on from the customers. And then 3 years ago, Jabil came on board. They've been a long-term customer, and they approached us with the potential to buy us. And that was mainly looking at our sustainability side of the business. They were looking at what they were doing, the massive global operation, but they didn't really have something in the sustainability line of things in electronics, and they saw us as a good opportunity for that. So yeah, they've been on board now for 3 years.
Okay. Yeah, it's interesting. The bigger organisations are clearly acting as the sort of pathfinders in the whole sustainability and circular economy. They've got the resources, they've got the incentives.
Yeah.
And I guess that's what they saw in you.
Yes. Yeah. They were looking to sort of have an avenue in that area to help them when, they need the help from one of their internal companies, and also to grow the business as well.
Yeah. And you mentioned they're kind of growing with your customers. And that's interesting, because if my sort of second question really is relating to what's happening right now with a lot of your customers, because there are shortages emerging quite dramatically, driven by material constraints with some of the conflicts currently underway, but also some real demand shifts in terms of data center and AI sort of activity.
Yeah.
Is that somewhere you guys now slot in?
Yes. Yeah. I mean, in a lot of cases for some of the bigger customers, we're not necessarily a permanent solution. In a lot of cases, what we are is we can fill the gap. So while this component crisis is going on, we can help you get through that.
Yep.
And then obviously the component crisis stops, you're going to move back to your usual supplier, you're going to buy those parts again. But we sort of, we fill the gap when there's an issue.
Like an emergency service, effectively.
Yes. Yeah. I mean, our customer list is vast. Because we've got our key customers that come to us for the returning services, but if a customer runs into an issue and they need it fixed, they'll come to us. We'll work with them for 3 months. We might not hear from them again for another 5 years. Yeah. It's just the nature of the business that we're in.
But so you can be on speed dial effectively.
Exactly.
And so as soon as that, because looking at the supply chain at the moment, the word is resilience. And given the amount of time it takes to introduce capacity into that semiconductor sector, there's always that gap, I guess.
Yes.
That you need to fill. And how quickly, it spurred another question actually, how quickly can you respond? If a customer comes to you with, an allocation issue on a particular component, they need to look at alternatives or whatever, what sort of response time?
I mean, it's very dependent on the requirement, obviously, but it's fairly quick, and we're fairly flexible as well. If it's a large requirement, then we can offer batch shipments, drop shipments. The process would normally, with Reclaim especially, would be that they would send some samples, we would reclaim them, we'd test them, we'd reball them, retin them, carry out all the services that they require, send them back. They would carry out their own internal testing, and then give us the go-ahead to carry on with the rest of the batch. But I mean, turnarounds range from anything from 10 days to 28 days.
Okay, yeah, sure.
Yeah.
And there's typically that sort of test cycle at the beginning.
Yes.
Where they can validate.
Yes.
Validate the work.
I mean, from our point of view, there's no point in us charging on with a batch of 1,000.
Yeah.
And then the customer not finding out until the end. Sure. So a lot of the customers will request it. If they don't, we'll try and push that as well.
So regarding the kind of current shortages that are taking place, in particular, memory seems to be compressed at the moment. What sort of devices and technologies are you seeing right now?
We're seeing our customers sort of suffering with the move from DDR4 to DDR5. obviously that means DDR4 is less available to them to purchase at the moment. But, the redesign process for PCBs moving from DDR4 to DDR5, in some cases, a very long process. Okay. So again, we've coming in and we're filling that gap while they're doing that. They're redesigning their PCBs to cope with the DDR5 rather than the DDR4. And in the meantime, while their design teams are working on that, we can reclaim their DDR4 devices from old PCBs, so they can reuse them again.
Fantastic. Yeah, so that's a real classic circular economy motion
exactly.
there. So they're taking used boards or stock boards or whatever. They're coming into you. They've got DDR4 on them. DDR4 on them. You're recovering and reclaiming those. Those are going onto the new boards, and that's gap filling during that redesign process to bring them up to DDR5.
Yeah.
Okay. Yeah. Interesting. Now, everything you've mentioned about sort of component recovery there, I've got in my mind's eye how that might work from an engineering point of view. Could you, without giving away too many trade secrets, just take us through the sort of step-by-step process of how you would achieve that? So let's imagine we're using that DDR4 to 5 as an example, and some of those boards have come in. What's going to happen from a technical perspective? How are you going to achieve that process?
I mean, the first thing we've got to clarify from the customer is whether the PCB itself is required to be returned in a potentially usable condition in the future, or whether the PCB is scrap.
Okay.
Because that sends it down one path or another. If the PCB is scrap, that's, from our point of view, that's kind of ideal, because it doesn't matter if parts fall off from the underneath. What we're doing is we're trying to get the critical parts off with the least amount of heat and the least amount of damage risk to it. So if we can add extra heat from underneath and all the parts on the underneath fall off, that's not an issue, because we're getting it off as quick as possible. If it needs to be reused again, then it will be a mixture of top heat and bottom heat more so, and it will be monitored a little closer because we don't want to damage the PCB.
Yeah.
So we've got bespoke tooling, we've got bespoke systems, we also got commercially available systems that we've modified a lot of the equipment that we've got to suit this. So yeah, it's on a case by case basis. Yep. We can have a PCB coming in that's 40 centimeters wide, or we can have a tiny one coming in. So there's a lot of tooling to be purchased or made internally. We've now got a 3D printer, so we're making a lot of that ourselves as well.
Okay.
So,
yeah, so it's application specific.
Yeah, very much so.
And I'm assuming we'll come on to this later, but I guess volume specific, technology specific, application specific.
Yes, I mean there's cases where I referred earlier to the parts coming in on pallets. We've had parts by the tens, 50 or thousands. In that case, we'll set up a bespoke line for that part, for those PCBs.
Yeah.
But if we're getting just a 50 off, 100 off here and there, then we can still set up an area for it. But for the larger inquiries, we've got a dedicated room upstairs in the factory that is for those large scale projects.
Is it an automated process? Is it a manual process? Semi-automated?
It's a mixture.
Yeah.
Yeah, it's very much a mixture. We try to automate it as much as we can. We're sort of, I say in the last 2 years, maybe a year and a half, 2 years, we've adopted the cobot robot arms that we're using. So that obviously helps a lot. It cuts down on handling and it's quicker.
Yeah.
Yeah.
And what are the sort of technologies involved in actually getting the heat into those components? Is it hot air? Is it infrared? Is it something?
Yeah, it's a mixture again, a mixture of both. Again, very application specific, depending on what we see, what the engineers have read in the data sheet about the heat requirements. We'll use either IR, it's a little bit of a gentler heat, or we'll use hot air. I mean, IR is obviously the preferred method for some of the larger parts.
Yeah. And in terms of process control, if you read the data sheet on a lot of semiconductor devices, it's very specific on how many times it can be reflowed and temperature windows, etc. How do you manage all of that?
If we're removing, for BGAs, for example, if we're removing a BGA, there's this, it seems to be a bit of an industry myth, to be honest, in my mind, that, we've got 3 or 4 reflows in every component. I don't know where that came from. I don't know who said that in the first place, but if it's a BGA, for example, we can remove it using heat, but then to reball it, we don't have to use heat.
Right.
So they've used one reflow profile to fit it. We've used one reflow profile to take it off, but we're not going to steal another reflow profile because we can reball it on the laser.
Okay.
So the laser is sat at an inner atmosphere, it's in a room temperature.
Yeah.
So we're not running another reflow profile on it.
Yes. Which reminds me of another sort of industry myth in terms of component shelf life. Which brings me on to another question, actually, which I'm gonna throw in because I hadn't thought about this, which is once a component has been safely removed, say it's a BGA and it's been reballed, how is it then packaged and handled between you and the customer? Because I guess that's going to be pretty important. ESD, safe, moisture safe. So it's going to go, I guess, back into what would have been its original packaging environment.
Yes. Yeah. So, I mean, we'll, again, each customer's got their own requirements. So if those requirements don't match up to what we would expect, we'll advise them on that. But in most cases, we'll just look at especially on the larger chips, we'll look at the MSL level. Everything's pre-baked on the way in and post-baked on the way out.
Right.
So everything that comes into the building is baked on the way in and on the way out. So then it's vacuum packed with desiccant and shipped out that way. Yeah.
So we've discussed that kind of confidence building in terms of process control and packaging. I'm guessing there are going to be some industry standards sort of underpinning all of this.
Yeah.
So just out of interest for our viewers, what would the sort of key standard there be?
We are AS 9100 qualified. So that covers most. I mean, a lot of that covers mainly for our aerospace and military customers, but it also gives our other customers confidence knowing that we're doing that kind of work.
Yeah, sure. So process control.
Yeah.
Okay. So what I would really like to do for our viewers is paint a picture in their mind of where they fit into the sort of Retronix supply framework. And I've got this idea in my head of a sort of quadrant graph, which is volume up one side in terms of the number of products that need sort of reworking, reclaiming, etc., and complexity along the x-axis. Could you just sort of set the scene, give me an indication of the sort of lowest cost, highest volume product that falls under your remit, all the way down to the lowest volume, highest value components that you'd work with, to sort of provide this window where our viewers can sort of see themselves.
Yeah. I mean, we've had customers that the reclaim isn't necessarily from an environmental or a sustainability point of view. They've made a mistake. So they've run thousands of PCBs without realizing that they've made a mistake. But they have some high value parts on them. The fairly low cost PCB sort of high value part may just be £20, £30. So we've had that on a fairly large scale, where we've just had to reclaim the parts for them to refit on the next run.
What sort of numbers? Hundreds, thousands, tens of
thousands.
thousands?
I think the one I've got in mind was at least 10,000.
Right.
10,000 PCBs that were run incorrectly across multiple lines. Purely because the machine was loaded incorrectly at the start, and it's a 98% automated process. So they didn't realize until the very end, and by that point, they run an awful lot.
So it could be, I find that interesting, it could be as simple as a component orientation that's been missed, or maybe a part number out
Yeah.
of sequence or date code or something, and because that part is being, as you say, manufactured across maybe multiple surface mount lines, you do end up with a sizable batch
Yes.
before
Before it gets noticed.
before it's got picked up at functional test or something like that. Yeah, interesting. And now let's go to the other scale. In terms of single component value, what's the most expensive thing you've ever recovered?
At the moment, I would say it's AI. AI chips are proving a challenge. The industry's been, for the last 40 years, have been geared up very much on making things smaller, obviously driven by mobile phones, etc. And now all of a sudden, AI chips have come along, and some of them huge. We've had 120 mil square,
Right.
BGA, 22,000 spheres on it. And obviously it's low volume because this is just development stages, but the customer still needs to reclaim these because they're very, very valuable. They're bespoke devices to that customer. So it's crucial that they're recovered and reballed, looked after, and can be reused.
Right.
But I mean, this could be 2-3 PCBs, very low quantity, but very, very high value.
What would the value of a device like that be? Tens of thousands?
Tens of thousands.
Right. Wow.
Yeah, definitely. I mean, it's setting its own challenges, really, because, like I say, the industry, we've been gearing up for everything getting smaller, and now suddenly things are getting larger again.
That's an interesting trade. That is not something I had really considered. As you say, for the last 50 years, the industry has only ever dealt with ever smaller.
Yeah.
And now you're saying that the industry, or certain parts of the industry, is now focused on ever bigger.
Yeah.
Yeah, interesting.
The tooling and everything in the industry has obviously changed over the years to suit the smaller stuff, and now suddenly we're being faced with this, 120 mil square BGA that we're required to remove and reball.
Right. And on BGAs, I've worked with sort of BGAs, surface mount, for ever since they appeared, really. And even on a standard BGA, solder voiding is not uncommon, dry joints, etc., difficulty X-ray inspecting that type of interface. Are those the sort of problems that companies are going to encounter that you can help with?
Yes. Yeah. We do an awful lot of PCB rework for customers, and an awful lot of just X-ray inspection as well. Lots of CEMs still haven't got a X-ray on site, so they'll run the first 5, send them to us, we'll X-ray and say, yeah, it looks like you got the profile right, and then they can go ahead with the rest of the batch. And then if they haven't got the profile right, we've got them into X-ray, and we can then obviously offer them services to reflow or remove, reball and refit.
Sure. That brings me on to the laminates and PCBs themselves briefly, if I may. You mentioned earlier on that there are sort of 2 paths through the process as to whether the PCB itself wants to be recovered or would go to scrap. Yeah. In terms of larger component sizes in that sort of hyperscale AI world, the boards are getting thicker as well. So, I'm hearing rumours of 100-layer boards, etc. In a crazy situation where you had a 100-layer board where they wanted to keep the board and keep the part, can you do that?
We never say no. We'll always try. In that case, in cases like that, we'll ask the customer to send one in to us. We may end up creating some bespoke tooling. We'll create some bespoke profile, and we'll do what we can. If we really can't do it, we'll tell you we can't do it. I think the thickest PCB that we've faced so far is a 42-layer, and we were successful with that. We've not been approached yet for anything in the hundreds layers, but I'm sure we'll find a way around it.
And that takes me on to another industry sector that I thought we could discuss for a little while, which is, moving from the AI data centers where you say devices are getting ever bigger, into maybe some of the mission critical aerospace defense type environments, which from my perspective in terms of supply chain are a very different kettle of fish, because you're talking not the latest chips, but actually legacy devices. You're not talking about the latest designs, established designs, but you are talking about products that are heavily standards dominated, and also in short supply due to some of the conflicts that are occurring around the world at the moment.
Yeah.
So what does that market for you look like right now?
I mean, for the that sort of area for military and aerospace, I'd say the majority of the work that we carry out is the alloy conversion, and that sometimes is alloy refresh, to be honest, because some of the parts, like you say, they're legacy parts. They've not necessarily been stored very well, so they'll come to us. We'll run some soldability checks on them, and again, similar to the X-ray issue a little while ago, if they fail the soldability test, then they're on site with us anyhow. We can fix that.
Yeah.
So it's, poor storage because of legacy parts, and it's just the alloy conversion side of things is what we're mainly doing.
Right.
And the military and aerospace area is somewhere that hasn't particularly dipped their toe into reclaimers yet. Okay. I can see them having to in the future, and they know where to come, basically, because we're dealing with the majority of them anyhow.
So in terms of the alloy conversion, what you're talking about there is taking, not taking components off boards and converting, but actually taking essentially new stock, lead-free. You're running that through a process where you're removing that lead-free solder and retinning it with military-grade leaded product. But as you say, as the availability of even that new stock starts to diminish, then they may well move into a reclamation process themselves.
Yeah. I think I can, just from conversations I've had with various customers, it is something that's in discussion with that industry at the moment, whereas if I'd have spoken to them 5 years ago, they wouldn't have considered it.
Right.
So it is something they're moving towards.
It's interesting. We had a conversation, I had a conversation a little while ago with quite a high-ranking army officer, essentially, involved in procurement. And the discussion we had was quite interesting because it began by him explaining to me that the component they need for a board that's failed is already somewhere in their supply chain. The chances are it's on a board, in a box, on a shelf, in a warehouse, somewhere. And it was the logistical process of finding that board and then entering a service such as yours to recover that component. So I can see that as a process starting to emerge. They're clearly thinking about it, because that's exactly what that chap was saying.
Definitely. I mean, I was at a Make UK event last year, and there was a talk from, again, someone fairly senior in the RAF, and they were talking about when we're finally at a point in Europe that we're less reliant on overseas chips that are currently in all of these devices, that there will be a pullback at some point. There will be a recall of pretty much everything that's got anything in it that's either Taiwanese, Chinese, and that those parts will be taken out and replaced with European or American built chips.
Interesting.
So I put my hand up quite quickly to let them know we're available.
Do that
on that one.
Would you see maybe you see this already, I'm wondering whether in terms of supply chain resilience, organisations like that would arrive at a position where they would recover not to reuse, but recover to put into stock.
Yes.
Do you see that?
Yes, definitely.
Okay.
Yeah, I mean, in some cases, it's it would be recover to, from our point of view, recovering the component, sending it back to the customer. They may just be reclaiming the die from inside. So it might just be that they're not interested, the footprint's changed, but the die is the same.
Right.
And then they'll go to various other customers, various other companies that can reclaim the die from the inside the component and repackage it for them.
Okay. So die reclamation is not something that you're doing at the moment, but you've got companies you can work with.
Yes.
That could do that.
Yeah.
So you can do footprint swap outs with that core die remaining intact. Interesting. And the other sector that I was going to ask a couple of questions about was just a sort of industrial world at the moment. We were at the MAC 2026 exhibition, and it was full of robots. And these robots are getting quite clever, and they're packed with edge AI, and they're loaded with electronics and circuitry, and those products are safety critical because they're going to be operating often within the vicinity of people. So redesigns are going to be difficult and expensive to achieve. They've got long duration lives. They're supposed to be durable. What sort of applications do you see in the industrial sector?
I think just the industry overall is moving so quickly that, like, probably by the time those robots are designed, first ones are run, batch quantities are run, and then they're into, the end of life place that they're going to start performing. The technology's changed. It's got better. So I think it's going to drive the need for an incessant change and upgrading. Yeah. So in some cases, they'll, what we've done previously for customers is they've pulled data center PCBs back, and all we've done is change out, one of the ICs on it because it's become a better speed grade in the meantime that it's been loaded. And I think the way the industry works so quickly like that will actually work in our favor for reclamation. And I think it's going to make reclamation a little bit more standard.
Yeah, it's an interesting thought because the speed at which industrial equipment is needed to be upgraded and enhanced traditionally has been quite modest and slow. But the introduction of this kind of edge AI type componentry is going to, I guess, drive a faster cycle in terms of product improvement and product upgrade. Yeah. So rather than obsoleting an entire circuit board, which is already qualified and classified and tested, you can just come in and maybe upgrade microprocessor or microcontroller or the memory. Just out of interest, what would be, on a control circuit like that, what type of device would you typically be coming in to recover and replace?
In a lot of cases, it could be the memory. It can be, especially on parts like the robots, it could be the AI chip. It's whatever the customer requires, basically. But and it can just be a different speed grade, a different revision, slightly faster, slightly more intelligent chip. And we'll just remove and replace with a new part. Yep. Or if it's become obsolete, then the parts that we're taking off, in upgrades, a lot of the time 85% of the PCB is still exactly the same. Yes. It's just 15% of that is changing. So you're throwing away this PCB over here, but it's got 85% of the parts that you need for your new PCB. Yeah. So we can help with that and reclaim that 85%.
Yes, and that is such a logical step. You'd wonder why anybody would do it any other way. Yeah. Right, Rob, I think we've definitely raised awareness about the types of services that Retronix provides and how they align up with the challenges that manufacturers have got. I think we've covered the whole subject of process confidence in terms of process control, in terms of the process steps, and some of the standards underlying that. And now I wanted to just talk about trust in the brand and trust in people to get that job done. Because then we'll have kind of completed that circle. So the question I'm going to ask now really is the scale of the organisation, number of people employed, how long you've been around, maybe some of your actual engineering background to give us an indication of the sort of level of engineering skill there. And then maybe we can look at some crazy figures. How many boards can you process a week? How many parts have you saved over the history of the company? So, global footprint. Let's start with that. Where are you?
We're in the main base for Retronix itself is in Scotland, in Coatbridge, just outside Glasgow. We've got another facility in Austin, in Texas. Between the two sites, we've got, I think it employs about 200 people. Again, that fluctuates. Again, customer driven. It will fluctuate in and out because of projects coming in, large scale projects coming in that we need to add some people to. We have another site also in Florida, working on a slightly different side of the business. But there's also, there's a footprint there too.
Okay. And how many boards are you kind of processing a month across those facilities? What's the scale of throughput?
For the Reclaim side of things, we have done a project where it's been up to 1 million PCBs.
Wow.
Yeah.
Per month?
Yeah. So they're coming in, these are the things coming in on pallets that we're reworking for a customer.
Right.
Reclaiming one part, adjusting some other parts, repacking,
okay,
shipping out again. And that was spread across both the facilities, the Austin facility and the Scottish facility.
Okay. So in theory, you could scale up to handle any volume essentially.
Yes.
I mean, that's pretty that's pretty significant.
Yeah, I mean, we've got, like I said earlier, we've got a whole footprint in the Scottish facility set up purely for large scale projects. And if there's nothing large scale in at that moment, we're not butchering that area. We're not doing anything with that area. That's there, set up, ready for large scale projects.
Back to that kind of emergency service.
Exactly.
Yes.
We never know. Yeah, we never know what's coming.
So you've got kind of capacity.
Yes.
Sitting ready to roll.
Yeah.
Yeah. Okay. Interesting. Have you got any idea how many over the history of the company, how many parts you saved? So.
I mean, 33 years. I mean, the company did start out as supporting people like Motorola and people like that up in that area. So we've almost gone full circle back to, it did start out reclaiming parts and reworking parts, and now 33 years down the line, we're still doing it. Right. So I'm probably in the area of 25 million, I would say, at least 25, 30 million parts.
Wow.
Which is an awful lot of parts, awful lot of money saved for customers, an awful lot of parts kept out of landfill as well.
Yep. Yeah. So, when you're recovering a part, the benefit to that is to the manufacturer themselves, because they've got access to something they didn't have before. It's a benefit to the planet because potentially that part or the entire circuit is not ending up in landfill or some form of recycling. One other angle that did spring to mind is that it's also keeping that part, but all the other parts on that board potentially out of the sort of grey market, counterfeiting, unauthorised and uncontrolled market. So would it be fair to say that that's a sort of secondary benefit?
Yeah, definitely. I mean, it's one of the reasons that, from my point of view, my background was at a CEM, and one of my jobs there during my engineering stage was counterfeit protection. Mm-hmm. So putting in counterfeit protocols, and some of the stuff we saw coming through was quite shocking, to be honest, which led to a bit of a fascination into that area of counterfeiting and anti-counterfeiting. So being able to keep high value silicon out of the hands of these counterfeiters is a massive benefit, to be honest.
And just focusing on yourself briefly in terms of this trust, I'm introducing you to our audience, and I hope in the future to be able to personally introduce you to engineers that we work with. You're in a rare position in terms of your sort of skill set, and we'll come on to your involvement in standards development. Yeah. Can you just give me, to give our audience an appreciation of the level of knowledge that you've got on this subject. What's your path been through the electronics industry today? Where do your skills lie?
Well, previously I started with a company called Chelton, which were then bought by Cobham. So my background, I started in the industry in the military and aerospace sector, working as an RF test technician, and then moved on to Custom Interconnect Limited in Andover, and worked my way through there from test to becoming a trainer, a production support engineer, customer support engineer, production engineering manager, customer account manager. So all through all the stages, it's all been very engineering focused. From a production engineering point of view, I'm not going to help anyone designing a PCB particularly, but I'm going to help you build it. I've seen pretty much all of the issues that can occur at 13 years in a CEM.
Right.
So that put me in good stead for when I moved to Retronix. I know the issues that CEMs are facing, and I know we've got the facilities and the skill set to fix them for them.
Right. So, yes, truly seen it, done it.
Yes.
In a big contract manufacturing environment.
Yeah.
Yeah.
Yeah, 13 years there.
Yeah.
There wasn't an awful lot that we didn't see and we didn't have to fix and, overcome. And to be honest, if I'd have known, for a lot of that 13 years, I didn't know Retronix existed. Mm-hmm. If I had have known, then, in the last 5 years I was there, we were dealing with Retronix, and that's how the knowledge came of them.
Right.
And that's how the connections were made.
Which leads perfectly into a discussion around standards, which is where I'd like to spend a little time, if we may, because it's the ultimate confidence and trust builder.
Yep.
Now, my understanding is that there is a standard for component reclamation in the pipeline, and my understanding is that you are one of the originators of that standard. This, I would imagine, is going to be a game changer in my mind.
Yeah.
Because, as you say, there are an awful lot of sort of myths floating around in the industry in terms of how long components can be stored, how many times they can be reflowed, how reliable they are after those processes, etc. And an industry agreed standard on that would iron all of that out, I would imagine.
Yes.
Am I correct in thinking that? And just explain your involvement in that, because people need to talk to someone who knows about this. Then clearly you're someone they need to talk to.
Yeah, I mean, it goes back to the time in the CEM. I was a IPC trainer, which meant going out to some IPC events, getting to know some of the IPC committee members, some of the higher up people at IPC. I think probably 4.5 years ago, I approached some of them with the suggestion that a standard worth looking into is Reclaim. That was at the point where we were seeing a definite uptick in that, I think maybe driven by some of the component shortage issues around that time. So I approached them, they went away and discussed it, and then a few months later came back to me and said, yes, we're interested in doing that. A committee was put together, and we've been meeting regularly now for the last, I'd say maybe 2 years. Yeah, 18 months, 2 years. And we are very close. Right. We're very close. I had a Teams meeting on Wednesday just gone, and we are, I'm fingers crossed, first draft should be out July, August.
Okay. That's this year.
Yes, yeah.
I find it fascinating that a standard like that doesn't already exist.
Yeah.
Is there a reason?
There's I mean, we did take a lot of it we pulled from, rather than reinventing the wheel, we pulled a lot from the 74C, the rework standard. So a lot of it's covered from there, but there was an awful lot of angles. That's just about reworking. That's about removing a part and fitting a part. It's nothing to do with what you do with the removed part. So what we had to do is add all of those standards in, all of that side of it in.
Yep.
Yeah, it's been quite a long process, but from talking to other people on the committees that have been involved in other standards before, it's standard.
How many people are on that committee, and what sort of organisations do they represent?
We've got a stand. I'd say there's 12 of us that are meeting all the time, and then there's others that drop in and drop out from various other IPC areas. And we've got people from component suppliers. We've got people that do similar work to Retronix on the reclaiming over in America. We've got people from the Department of Defence. We've got people from very blue chip companies involved in it. So yeah, right. It's there's people been added as we've needed knowledge on certain side of things. One of the guys that's been added recently is more approaching it from a testing point of view. We needed some more test input, so he's come in to advise us on, because this standard also covers removing a part to carry out analysis on a failing part. Right. Because if you're removing a part and you want to find out why it's failing, you need to make sure you're taking it off and not causing another failure as you're going. So he sees that ties in with this, so we've made some adjustments to the standard to suit that side of things as well.
Yeah. So yeah, you don't want to compound the failure by the process.
No, you want to remove it in the safest way possible, so that you know what the problem was while it was on the PCB, not that the removal itself has caused the problem.
Yeah. On that subject of the standard relating not just to the removal of the part, but what happens next. Two things could happen to that part, I guess. They could be returned to the customer whose board it was, or they could re-enter the supply chain.
Yes.
How does that work?
That was a bit of a bone of contention at the last IPC meeting. Well, the one before last IPC meeting in Anaheim. And the suggestion was made that we just look at this first release of this, talking about returning the parts to the people that have supplied those in the first place. Yeah. So from our point of view, our customer would approach us with 2,000 PCBs. They want to remove 3 parts from each PCB. We're just going to remove them, and we're sending them back to those guys in the first place. They know the full provenance of the part. They brought it in the first place. When you start looking into reselling the part, it opens up a whole different amount of issues from traceability wise. So that's something that some IPC guys are working on in the background for the second release of the standard.
Yeah, interesting. So it is in discussion then.
It is in discussion, yeah. But rather than hold up the first release, we wanted to get this out there first, just talking about returning the parts to whoever's brought them in the first place.
Yeah, so the logic there is that original or that OEM would already have the traceability through their purchasing platform, and so they know the provenance of that part at that point. Yeah, okay. It was interesting there, just as an aside, you mentioned that, PCB might come in and you take 3 components off. What's, just a random question, what's the average number of parts you would take off a PCB? I'd assumed it was just 1, but clearly it's more than 1.
Yeah, sometimes it can be, we've had where it's been 10 to 15 parts, we've had where it's been 1. Right. I don't think we've ever had anything dramatic where it's been sort of, 25, 50 parts. It tends to be the higher value parts, or in some cases it's not necessarily the higher value, it's the higher requirement. If that part's gone obsolete, or if that part's on a 40-week lead time, then suddenly it might be a £3.50 part, but the need to the customer is based on their need rather than value in a lot of cases.
And would there be, again, it's a sort of crazy question, around about the time of the component shortages during COVID, that sort of thing, there were rumours floating around of purchasing departments buying modules and PCBs, etc., to literally recover that one part that had gone obsolete or shut down on the supply chain. That's a real thing?
We saw that. We saw that personally. We'd have customers contacting RS Farnell for modules, having RS Farnell ship them directly to us, for us to remove one or two parts and then send them on to the customer.
Right.
You know, someone in their engineering departments at these CEMs or OEMs worked out, yes, we can't get hold of this part for 52 weeks because of the component shortages issues, but they are on this module.
Right.
And RS, Farnell, people like that have got thousands of them in stock.
Yeah.
So they were willing to spend that extra bit of money.
Yeah, I'm imagining development kits and reference
Exactly.
designs and all those things just sitting on shelves.
Yes.
Where they can be recovered to save a much larger assembly, many times more expensive.
Exactly. And it ties into the component shortage crisis and the reclaiming issue. And we're perfectly positioned to help people with that.
Right. And just going back to the standard, you're going to be available, I guess, to talk to people, and you'll be at conferences and things when that comes out. How do you think that standard is going to impact first? I would assume it will just open doors to companies that have been too nervous to enter that sort of workflow.
I think so, yeah. It's going to give people that are already doing it a little bit more confidence in doing it. And, you know, I've run into companies that say they can't do it. And, you know, bearing in mind, I know some of the companies that we are doing it for. So I know, you know, what they're working on, the kind of things they're working on, the kind of industries they're in, and they're quite happy to do it.
Yeah.
And then I run into other companies that say because their quality procedure says you mustn't reclaim.
Yeah.
But that quality procedure might have been written 10 years ago, 15 years ago, and an awful lot's changed in the industry since then. And I think once that standard's out there, that's going to give those kind of customers an awful lot more confidence to go ahead with it.
Yeah, it's an interesting subject. At a complete tangent, it's you know, when I visit manufacturers, talk to engineers, so much is habit in those organisations.
It is,
and so yes, not wanting to move out of a process control they had non-standardised. It would have been put there by an engineer who may have retired or left or whatever, and it leaves that kind of almost like a vacuum around that subject. And really the only way to fill that is to come in with an industry organised standard, which can burst that bubble and then they can move on.
Yeah,
that sounds
100%. And it's in some cases it's the larger the company, the more they are have that mindset, to be honest. Because you know, the organization's so big that nobody's there to particularly question, you know, to delve into questions like this. So I think the release of the standard, and IPC is obviously going to push it heavily. We're going to push it heavily. All of the committee members will be pushing it heavily. And I think it's going to make a big difference in the industry for, multiple reasons.
And I think I spoke recently to Debbie McDade at ART, another UK-based IPC organisation. My understanding she's been involved in that as well.
Yes. Yeah, she floats in and out. Like I say, we've got a core members of maybe 12, 15 of us, and then other IPC members that are involved in. Debbie's part of the standards committee anyhow, so she'll dip in and out to see how we're getting on, keep an eye on things.
So I think as soon as that standard emerges, then maybe we should sit down and write something about that, or produce another version of this maybe, and discuss that in detail, because I think that, as you say, that's going to be a real line in the sand.
I think it will, I mean, like I say, the benefits to it are, you know, there's financial, there's to help through component shortage crises, there's keeping parts out of landfill, you know, counterfeit, and then sustainability as well. And the environmental policies that a lot of the electronics companies are trying to aim for nowadays, this will help if you can put down in that requirement that you are reclaiming parts, then that's going to help you towards those standards also.
Just towards the end, I was going to come on to some of the sort of legislative drive behind all of this, but just now referring to that sort of thing, you know, I'm seeing large organisations, things like the NHS, for example, putting policies in place now where tendering for contracts is going to require a sort of genuine commitment to the sustainability roadmap.
Yep.
You know, the NHS is products and services full of electronic products, some disposable, some long-term, some super high value. So it looks to me as though that type of sustainability and circular economy roadmap is going to have to be built into that.
Yeah, definitely. I think there's an awful lot more of the industry looking at environmental processes nowadays. Even to the point, I've got a handful of customers that I used to visit 3-4 times a year, maybe, that now request their suppliers don't visit them. They have 2 supplier days a year, and they get all their suppliers on site at the same time, and they talk to everyone at the same time. So from a couple of hundred visits across their suppliers, lots of driving back and forth, suddenly it's down to 2.
At this point, Rob, it might be interesting just to kind of really round out where the industry is heading and where Retronix and yourself fits into that process. Because when I look at the sort of commercial incentives to enter into a more sustainable and circular business model, and I look at the legislative pressure that will be forcing businesses to do it, the two seem to be coming together now. And 2026, for some reason, is a year, from what I can see. It's interesting that your IPC standard comes out this year. You know, for example, we're seeing manufacturers, original equipment manufacturers, moving more to a product as a service type model. So rather than selling a motor controller, using it and landfilling it, it's now build a motor controller, sell it, maintain it, repair it, resell it or reuse it, bring it back to the OEM, upgrade it, resell it again, and put it into this circular model, maybe where hardware and software is updated on a rolling basis for as long as feasible. And that product as a service model we're now seeing announced as policy for large OEMs. Likewise, I'm seeing automotive manufacturers now setting up facilities in Europe to disassemble their vehicles, which is a very different model to the previous one. I'm seeing right to repair legislation starting to feed through into the electronics industry. Certainly next year, I think, if I've got this right, you won't be able to buy a mobile phone, for example, anymore that is that you can't replace the battery in, and you can't disassemble relatively easily for repair. So all of this, including your standard, we seem to be reaching a tipping point almost.
Yes, I'd say
so. So in the conversations you're having with your customers, is this an easier conversation to have now?
Yes.
Than it would have been.
Yeah, like I say, going back sort of 5 years ago, talking to some customers about Reclaim, they don't even want to discuss it particularly, and now it's become, it's almost become the thing.
Right.
The reuse, the circular economy. There's more and more customers considering that side of things.
So you can see that my vision is that becomes a standard component of a product as a service business model. And as I say, we're doing case studies ourselves at Sustainable Engineering Alliance on just that, in classic examples of relatively high value industrial electronic products, to say like motor controllers and smart factory modules and that type of thing. And I'm assuming you would work in those sorts of fields.
Yes. Yeah, definitely.
So let's conclude with some future gazing. So let's look into the future, maybe say 10, 20 years. I'm seeing an electrified, digitized, automated world ahead of me, and a world where new business models will evolve that are more circular in their nature. I see more legislative and regulatory pressure to prevent environmental harm and damage, the whole sort of ESG type model. one day I imagine my family will have a humanoid robot to be a companion and a helper, and they'll be AI enabled and everything else. Where do you see the future of the electronics industry, and where do you see you fit into that?
Yeah, I think from our point of view, we've historically over 33 years we've grown with our customers, so we'll grow with the demand wherever that demand may take us. Like you say, I mean, on lots of things you say, I completely agree with on how it's going to move on. Obviously, AI is going to have a big impact on things. I've read things recently about wireless power and things like that. So, yeah, it never stops. Yeah. The industry never stops. It's constantly moving.
Data centers in space.
Yeah,
I'm reading about. Yeah. I think are you involved in the sort of energy sector, renewables and?
Not so much. It's one area that, I mean, oil and gas we had some inputs into, but the renewable side of things not so much at the moment.
Okay.
I can see again as things progress in that area, I can see that growing.
Yeah, power management.
Yeah,
motor control, that type of that type of thing. Yes, I read that. I think the project is now going ahead with the I think they're referred to as small nuclear reactors.
Yeah,
and I'd imagine they will be hosting all manner of electronic controls that will have longevity and quality standards behind them. So I can imagine that new energy sector.
I was at a military conference a few months back, and they were talking heavily about that. They're talking about these nuclear fusion reactors within literally a container size, because from their point of view, getting energy in and out is getting diesel in and out, is running generators, and every time you leave the base it's more risk. So it also cuts down on the risk, as well as basically you've got a full power plant in the size of a container.
I think that's a reasonable vision of the future, and a sensible one, and one in which the role of electronics is clearly going to play a very important role. And if, as I say, if we enter into this more circular reuse product as a service type environment, which is what we're witnessing, then ultimately the disassembly of printed circuit boards has to play a significant role in that.
Yes.
Because without that, you lose the ability to operate that business model. So I look forward to revisiting this subject on a regular basis, looking at case studies. Just to sort of conclude, do you see any, in terms of your company's investment in the future, where do you think the investments will lie in both people, facilities, technologies, machinery?
Yeah.
What's next for the organisation?
I think, especially on the larger scale projects, like I mentioned earlier, we're using the cobot robot arms. I can see much more investment into that side of things, because a lot of this work is it's repeatable. This is something that we could take a lot of this away from the risk of people doing it, and the repetitiveness of people doing it. There's still places further down the line for the need for that manual interaction, but the removal of components itself, if we're doing this on a large scale, hundreds of thousands of parts, that can be automated. So I'm seeing an awful lot more of the robotic side of things happening at Retronix.
And you say it's a sort of cobot style environment at the moment. And what just from my perspective, my interest, what are the cobots doing? What's their role?
They could be, at the moment, I've seen one of the projects we've set up, which was to remove a device from a PCB, so the robot will move it over the hot plate. It will be placed on a holder there, and then it will adjust. It will take that head off, put another head on, and that head will be a vacuum pen that sits on top of the component under pressure. So then as soon as that reaches reflow profile, it moves it away.
Right.
It then puts the component over here in one position, the PCB over there in another position, and it moves on to the next thing.
Right.
So it's all quite repetitive stuff. So having that done, and you don't even need to keep the lights on for the robots.
Yeah.
You can run them all night doing things like that.
Yes, and being a cobot type machine, flexible for different types of boards and different types of components.
Yeah.
Yes.
Yeah, we've got quite a good relationship with the University of Glasgow, and we're talking to them currently to have some of their robotics students, university level students, coming in to help us and for them to learn and see how these things can work in the real world. So it's a win-win for both of us. They can help us progress our knowledge as well in that state.
Sure. So investing, because that's another big question in terms of next generation workforce, training, STEM subjects, that type of thing. So so Retronix is involved in that in that process, investing. Yeah, that's great news. Well, I think that probably brings us to the end of this podcast. Rob, it's been a fascinating discussion. I can now visualize all of the reasons why you might want to recover components of circuit boards, retin components, test components, etc. That's now much clearer to me. I understand the scale from low volume, high value parts through to those millions of boards, which really did quite catch me by surprise. And also the trajectory in terms of the release of that standard, which is clearly going to incentivize a lot of companies, I would imagine,
100%,
to get involved in this process in a way they haven't before. So I look forward to having regular conversations and finding out how that goes. And seeing you at events. In fact, is Retronix. Have you got exhibitions, events, conferences you'll be at?
We haven't got anything in the plans at the moment. The only thing we've got in the plans is we are hosting a Make UK Defence event.
Oh, okay.
That's in discussion at the moment.
Right.
So we'll be hosting that on our site.
Yes. Well, yes. When events come along, let us know. And when we can help promote those for you as well to our audience. To conclude, we'll put a little call to action in at the end here. So we've got a big audience of engineers involved in design, manufacture, aftermarket. If they want to get in touch with Retronix, if they want to get in touch with yourselves, what would be the best way to do that?
Dropping me an email, to be honest, was probably the best way, or linking up on LinkedIn. We can help out in any way, basically.
And there's a website,
yes,
with plenty of information on those services. Okay.
Yeah, there's the Retronix website. There's also a quote request form on that website, so you can submit a quote request straight away that way as well.
Okay. And in terms of that call to action, a quote request, what sort of information do you require from a customer to be able to judge?
As much as possible.
As much as possible.
Basically,
photographs, bill of materials.
Photographs, bill of materials, data sheets, drawings, everything. The more information we get, the quicker and the better the quote you'll get back.
Okay, fantastic. Brilliant, thank you.